So in this question here, we've got a parametric curve, which we're going to call phi, and it's given as 2t sine t and 2t cosine t. So notice there's no x and y here because it's parametric. And we want to find the radius of curvature of this curve phi at pi over 4. So what we're interested in is when t is pi over 4, what happens to it? Now, notice here we've got 2t sine t, 2t cosine t. Now these are both functions of t. They're not functions of x or y at those 2 points there. So what we're going to do is define x of t as this one, y of t this one. So let's put it on here. So x is a function of t, and it's 2t sine t. And then y is a function of t, and that's what that one is there. It's 2t cosine t. Let's write that y a little bit better. 2t cosine t. Okay, right, now next thing we need to consider is the formula for the radius of curvature of a parametric curve. Now that is found with this quite complicated looking formula. So the radius of curvature, I'm just going to call it r, is the absolute value, and it's a ratio. So what we have in the numerator, we have the first derivative, so x dot, I'll come to that in a moment, and that's squared, plus y dot squared, so I'll come to that as well, and that's raised to the power of 3 over 2, very similar into the radius of curvature for a curve that's not defined by parametrics. And then we divide that by the first derivative of x multiplied by the second derivative of y, and subtract that by the second derivative of x and the first derivative of y. And then we close off the absolute value. So that's our formula. Now there's a few bits to go over here and what we need to explain and what each part is. Now x dot, what x dot represents, so x dot, that represents the derivative of x with regards to t. So that one there, I'm just going to write that as dx dt. That's what that represents. Okay, so why don't we do that? Let's find the derivative of x with regards to t. Well, here we've got 2t and sine t. So we've got one function of t and another function of t, so we're going to need the product rule. So the first one, let's go for the derivative of this. So that's 2, and we'll keep sine t. So 2 sine t. This time we'll keep 2t and take the derivative of sine, which is cosine. So we add 2t cosine t. So that's our x dot taken care of. We're going to square that in a moment, we'll come to that. And then what we can do now is find the y dot. So y dot, very similar case to x dot, that's derivative of y with respect to t. So y dot, let's take the derivative of this. Again, we've got the product rule. So this time let's keep the cosine, and we'll take the derivative of this. So we've got 2 cosine t, and then add on the derivative of cosine multiplied by 2t, while the derivative of cosine is negative sine. So instead of a positive, we'll have a negative. We'll keep the 2t and we'll have sine t. So that's our first derivative of x and y taken care of. So these are our building blocks that we're going to need to try and find our result for the radius of curvature. Okay, now what about the second derivatives? I see here we're going to need those. So those are going to need the derivative of these. So notice the derivative of that, fine, but we need the product rule again for this one. So let's first of all go for x double dot. Now x double dot, that's going to be the same as d squared x dt squared. That's the equivalent of that. So second derivative, hence we take the derivative of this. So the derivative of sine is cosine. So we've got 2 cosine t. And then we need to take the derivative of this using the product rule. So 2t, and then the derivative of cosine is negative sine. So we've got minus 2t sine t. And then this next one, we'll take the derivative of this and keep this. So we'll add 2 cosine t. Okay, now we can see from that 2 cosine t plus 2 cosine t, we can simplify, and then this will just become 4 cosine t, and we'll take that out. So that's our result for the second derivative of x. Now we want the second derivative of y for this part. So that's the same as the second derivative y dt squared. And so what we do now, we take the second derivative of this. So y double dot, so that's the equivalent, y double dot equals 2 cosine t, derivative of that, well that's just derivative of cosine is negative sine, so that's minus 2 sine t. And then we're going to need to subtract, so I'm going to put that on this line here, just so as everything's behind the minus sign. So we keep the 2t, take the derivative of sine, which is cosine, so that's minus 2t cosine t. And then if we keep the sine and then take the derivative of that, we've then got 2 sine t. So we'll add 2 sine t. Okay, right, let's simplify this off because this is looking a little bit confusing. So we've got minus 2t, minus 2 sine t, minus 2t cosine t. Let's come to that in a moment. But here we've got another 2 sine t, and it's with a minus. So we've now got minus 4 sine t altogether. And then we've got minus 2t cosine t. So minus 2t cosine t. So that takes care of that, and then that's all included in there. Okay, right. So that's that. Now what we want to do is try to evaluate all of these at pi over 4. So let's just take these marks off the board and evaluate them at pi over 4, and for this one as well. Okay, right, let's evaluate this one first at pi over 4. So x dot at pi over 4. So let's go for that. So we've got 2 times sine of pi over 4 plus 2 pi over 4 cosine pi over 4. So plus 2 pi over 4 cosine pi over 4. Okay, now sine pi over 4, cosine pi over 4, they are both 1 over root 2. So I can substitute 1 over root 2 for both of those. So now I've got 2 times 1 over root 2 plus 2 pi over 4 times 1 over root 2. Okay, now what can we do? Well, let's multiply this side by 4. So if I multiply this one by 4, I'll get the same denominator on the bottom, but I'll also need to multiply the top by 4. So then I'm going to have 8 over 4 root 2 plus 2 pi over 4 root 2. Okay, right, that's all well and good, but it's just, that's not working for me on the bottom there, that's root 2, so that's irrational. So let's multiply everything by root 2 over root 2. So root 2 over root 2, let's multiply everything. So then I'm going to have root 2 on the top, if I just do that. And then I'll have 8 plus 2 pi. And then on the bottom, multiply everything on the bottom by root 2. I'm going to have 4 root 2 times root 2, which is going to give me 8. So that's all going to be divided by 8. So I can put an 8 there. Okay, so now I've got root 2 over 8 times 8 plus 2 pi, but I can simplify that a little bit more. So now I'm going to have root 2 over 4 times pi plus 4, if I just put it pi first. So that'd be my first result for x dot at pi over 4. So let's put that result in there. So that's root 2 pi plus 4. And then all divided by 4. So that takes care of that. Now let's take this off the board and calculate the y dot. Okay, so where we see a t, we put pi over 4. So 2 cosine pi over 4 minus 2 pi over 4 sine pi over 4. Okay, so we know from the previous that this is worth 1 over root 2. So we've got 2 times 1 over root 2 minus 2 pi over 4 times 1 over root 2. Okay, so let's just multiply this out and just simplify a little bit. So we've got 2 over root 2 minus 2 pi over 4 times 1 over root 2. Let's just write that as 2 pi over 4 root 2, just like the last one, and what I wrote a pi for there. So 4 over root 2. So now to get the same denominator, just like I did in the last one, multiply top and bottom by 4. So then I'll have 4 root 2, and then that one will be 8. So now I've got the same denominators. Let's get the irrational root 2 out of the way and multiply everything by root 2 over root 2. So now I'm going to get, very similar to the last one, root 2 can come out the front. I'll have 8 minus 2 pi. So that takes care of numerators. And then 4 root 2 times root 2, that's going to give me 8. So that's divided by 8. And now I've got 8 minus 2 pi. I can simplify that by taking a 2 out and then reducing that. So now I've got root 2 over 4 minus pi. So it's very similar to the other one, but it's just 4 minus pi instead of pi plus 4. So let's put that in there as my result for this one. So I now got, let's just give ourselves a bit more room. So root 2 over 4 and then 4 minus pi. Okay, so that takes care of that. Right, let's take this off the board and let's evaluate this one. Okay, so where we see where we see a t, we substitute pi over 4. So 4 cosine pi over 4. So 4 cosine pi over 4. And minus 2 pi over 4 sine pi over 4. Minus 2 pi over 4 sine pi over 4. Okay, so that's that. So now we know cosine and sine pi over 4 are the same, they're 1 over root 2. So now we've got 4 times 1 over root 2 minus 2 pi over 4 times 1 over root 2. Okay, right, let's just simplify it off a little bit. So we've got 4 over root 2 minus 2 pi over 4 root 2. Okay, so now multiply this one by 4 over 4. That means then we can get the same denominators. So that's going to give us 16 on the top, 4 root 2 on the bottom. So that's all good. And now let's get the irrational denominator out of the way. Root 2 over root 2. So now, what have I got here now? So I can bring a root 2 out at the on the numerator. 16 minus 2 pi. So that's the top taken care of. And now distribute this root 2 with the 4 root 2. That's just going to give me 8. Okay. Now, very similar result to before, except this inside the bracket is going to be different because I just divide this by 2. Therefore, I can divide that by 2. So now I'm going to get root 2 over 4, 8 minus pi. So that takes care of that one. Let's write this over here. So now I've got root 2 over 4, 8 minus pi. Okay, right, let's get that off the board and let's evaluate the y double dot. Okay, right, so last one. Let's calculate this one at pi over 4. So we've got minus 4 sine pi over 4. Minus 2 pi over 4 cosine pi over 4. Okay, so that takes care of that. Right, so let's simplify off again. We know our sine and cosine pi over 4 is 1 over root 2. So we've got minus 4 times 1 over root 2 minus 2 pi over 4 times 1 over root 2. Okay, simplify off as we did before. So we've got minus 4 over root 2 minus 2 pi over 4 root 2. Okay, just like we did before, let's multiply this by 4 over 4. So then we'll have 4 there, 16 there. Okay, right. Let's get rid of the irrational denominator. So now times it by root 2 over root 2. So similar pattern as before. So root 2 stays in our numerator. And what I'm going to do is I'm going to take out the minus sign. So I'm going to put here now minus root 2. That way then all I need to write here now is a 16. And then plus 2 pi. Okay, so that would take care of that. And then now root 2 times that would just give me my 8. So now I've got minus root 2 over 8. And I can simplify that just by dividing all by 2. Minus root 2 over 4, 8 plus pi. Okay, so now with that minus sign carefully written into here, let's do that. So minus root 2 over 4, 8 plus pi. Okay, now just to make these all the same with the pi in second in the term, I'm going to rewrite this one to pi plus 4. To 4 plus pi. So they're all in the same format with the pi second. Right, that's great. Let's take this off the board and let's make a start on this because it's going to be a lot of algebra to get this one sorted. So let's do that. Okay, right, so we're in a great position. We've got all this stuff worked out. All we need to do now is plug it into our formula here for the radius of curvature of a parametric curve, and then we're away with the answer. But there's some complicated looking algebra coming up here, and let's see what we can do. So first of all, let's repeat what we've got there. So radius equals, let's keep our absolute value and our fraction, and let's see where we go. So starting with the numerator, we've got x dot squared. Now we've got x dot calculated here, so we need to square that. So what does that come to? Well, if we square this, we've got root 2 over 4 squared. So root 2 over 4 squared and 4 plus pi squared. So 4 plus pi squared. So that's all squared there. And then we're going to add this one squared, this one squared, our y dot. So now we've got the similar term, root 2 over 4 minus pi, all squared. So that takes care of that. But then this is all raised to the 3 over 2. So I'm going to give this a square bracket to help us recognise that so we don't get mixed up. Let's put my absolute value here. And now I've got x dot y double dot. Well, x dot is this one, root 2 over 4. So root 2 over 4, 4 plus pi. And then that's multiplied with this one. So I've got minus root 2 over 4. So if I just write root 2 over 4 for now, I'll deal with the minus sign in a moment, 8 plus pi. Okay, so now this is all multiplied, I can bring my minus sign into the front. Now I know I'm inside the absolute value or the modulus, but I'll deal with a minus sign just in case another one turns up, because I've got some other minuses to contend with. So that's that first term, and then we're going to subtract that. So I've put all this in a square bracket here as well. That will take care of that. And let's put this one in another square bracket separate. And as all of this denominator is in brackets, that will take care of the bracket. So x double dot root 2 over 4, 8 minus pi, and then y single dot, so y dot root 2 over 4, 4 minus pi. Okay, and then that's all inside that big square bracket. Right, okay, so let's see what we can do with this. So next line of working, so our radius of curvature, side the absolute value, let's keep the fraction going. Okay, let's see if there's anything we can do here. Well, I can bring my squared inside, so root 2 over 4 times root 2 over 4, numerator is going to give me 2, denominator is going to give me 16. So 2 over 16, I'm just going to write it as it is for now. I know we can simplify that, but let's not lose track of where we are. And then I've got 4 plus pi simply squared. Okay, so that's that. So let's put that in a big square bracket like it started off with. Then I can add this term. So I'm not breaking any rules of big mass with that. So this term squared again will also give me 2 over 16. And then I've got 4 minus pi squared. So that takes care of that. And that's all to the power of 3 over 2. Okay. Great stuff. That's the numerator a little bit more simplified. Let's take care of one side of the minus sign at a time. So let's deal with this one. So let's put it in a square bracket. Now, I've got very similar to what's going on up here with the squared. Minus root 2 over 4 times root 2 over 4. So that's now going to give me minus 2 over 16. And then I've got 4 plus pi, 8 plus pi. So I'll just write that like that for now. So that's that. So I can now close that off. And then subtract. So this time root 2 over 4, root 2 over 4, that can now just stay as 2 over 16 inside the bracket as a positive. Then I've got 8 minus pi, 4 minus pi. So that takes care of that. Okay, and that's all inside the bracket, a square bracket. I can just squeeze that in there. Right, okay. Let's do one more line of working and let's bring it back up the top and clear some space. So let's do another line here. So now the radius of curvature, that equals, we can expand these out first and simplify this. So we've got 1 over 8, 4 plus pi squared. Well, we can do that to multiply it out. So that's going to give us pi squared plus 16 plus 8 pi plus 16. So that's that one squared, and then add it to 2/16. Now 2/16 is 1/8. Now what I could do is I could just sneak in a factorisation in here and just add this one squared. So if I do that and just put that like that, that takes care of that. And then I've got this one expanded. Well, minus pi times minus pi is pi squared. I'm going to have minus 8 pi and then plus 16. But not forgetting, all of this is still to the power of 3 over 2. So if I do that to the 3 over 2, this 1 over 8 is also to the 3 over 2. So let's bring that inside the brackets. I can't take that outside the brackets just yet. Okay. Now my denominator, let's bring that down here a bit more simpler. So minus 2 over 16, that's going to give me minus 1 over 8. Keep it in the bracket. And then 4 plus pi times 8 plus pi, let's expand that. So now we've got pi squared plus 12 pi plus 32. Okay, I'm not going to mix these up just yet. I'm just going to keep these just as separate for the moment. Then I've got minus 1 over 8, and then I've got, I can leave the brackets now because I've got this minus here like this, that's fine. And then minus 1 over 8, let's expand that. So we've got pi squared minus 12 pi and plus 32. Okay, and that's all inside the absolute value. So that's what we got to so far. So now what I'm going to do is I'm going to clear some space up here and let's continue with this. Okay, so I've got that there so far. So let's do something with that. I've taken away the formula, but we're not going to need that for the moment. You can always rewind the video and have another look if you wanted to make sure. So absolute values, let's give ourselves a bit of space to work in, and our fraction. So what have we got here? So let's take out a 1 over 8 to the power of 3 over 2. So 1 over 8 to the power of 3 over 2. So we know what that is, but we'll come to that in a moment. And now we can do something with this now. Now we can just add these up. So I've got pi squared plus pi squared. So if I just put that 2 pi squared plus 8 pi minus 8 pi cancels, plus 16 plus 32. And not forgetting my indice of 3 over 2 to be included with this. So that's now my numerator looking a lot more simple. What about here? Let's look at this denominator. What can we do here? Just being careful with these minus signs. Now let's factor out minus 1 over 8. So minus 1 over 8. What can we do in here? Well, I know I can write that as it is. So pi squared plus 12 pi plus 32. And now what I could do is, as I've taken the minus 1 over 8 out and factorised it, I can just add these to these, and that will be valid with that minus sign taken out. So now I'm going to add pi squared minus 12 pi plus 32. Okay, right. Now we're getting this much more closer to what we want. So let's do something again. So R equals absolute value 1 over 8 to the 3 over 2. So I can do 1 to the 3 over 2, which is just 1. And then I've got 8 to the 3 over 2. And now what I can do is here, I can take a 2 out of that. So times 2. Now, just be a little bit careful here. I can't just take the 2 out of that and write pi squared plus 16 to the 3 over 2. I've got to take this out also to the 3 over 2. So that would take care of that. And then here, what can we do with this? So we're getting things to looking a little bit smaller. So now I've got minus 1 over 8. Pi squared plus pi squared. So that's 2 pi squared. Plus 12 pi minus 12 pi cancels out. Plus 32 plus 64. And notice I've got no indice here. So on my next line of working, I can take the 2 out of this and distribute it here. So let's go with that next and do something with this. So R equals, still absolute value. I haven't done anything with this minus sign yet. I will come to that at the end. So now I've got 2 to the 3 over 2 divided by 8 to the 3 over 2. So there's something I can do there in a moment. And then I've got pi squared plus 16 to the 3 over 2. Then we divide all of this. Right, let's take a 2 out of this. So if I take a 2 out of that, I'm essentially multiplying this by 2, which will give me minus 1 over 4. Okay, and that's going to leave me with pi squared plus 32. Okay, that takes care of that. Okay, right, let's take this off the board. Okay, right, let's do something here. So here, I can definitely turn that into a quarter because I've got the same indices. So absolute value, a quarter. Now what I'm going to do now is just raise my denominator to 3 over 2, because 1 to the 3 over 2 is just 1. So I've got 4 to the power of 3 over 2. Let's just make that a little bit bigger. 4 to the power of 3 over 2. And then I'm going to leave this. There's nothing much more I can do with that except work some crazy algebra on that to find what that is. And then I'm going to divide this by minus 1 over 4 pi squared plus 32, all absolute value. Okay, right, we're nearly there. So 1 over 4 to the 3 over 2. Let's work out what 4 to the 3 over 2 is. Let's just do that over here. 4 to the 3 over 2, that's the same as the square root of 4 cubed. So 4 cubed we know is 64. So basically what I'm looking for now is the square root of 64, which is just 8. So this just becomes 1 over 8. So let's just put my answer here now, because I'm ready to work on this. Now the absolute value I'm going to get rid of in a moment. So 1 over 8 times pi squared plus 16 to the power of 3 over 2. So that'd be my numerator without the absolute value. And then this minus sign, minus 1/4. Now if I've used my absolute value here and got rid of this minus sign because I don't want a minus, this is always going to be a positive, this is always going to be positive, so the minus sign can go. So I've got 1 over 4 pi squared plus 32. So pi squared plus 32. Now I can even do one last thing now. I've got 1 over 8 divided by 1 over 4. That's the same as, that could be 2/8. So that's 2/8. So that's 1/8 over 2/8. That just becomes a half. So now I can get rid of that and get rid of that. So now I'm going to submit that as my answer. Just make that into a proper 2 here. So my radius of curvature I'm going to declare as that, but that's not it finished. An estimate of that into my calculator is really, really close to pi over 2. Very much approximately. It doesn't come exactly to pi over 2, but it's within at least 4 thousandths. So 0.04% actually is what I calculated it to. I'm going to leave that for you guys to double check. But the parametric curve, 2t sine t, 2t cosine t, the radius of curvature at pi over 4 is approximately pi over 2. But that's its exact value there. And I find that quite an extraordinary result. Okay.